Welcome to the project demonstration of solar power micro inverter. So in this project we are going to implementing a inverter with two extra features like MPPT as well as boost converter. So here we are going to implementing that with the help of a PIC microcontroller. So the PIC microcontroller will continuously monitor the voltage from the input source. So that is a solar panel, and that will be through this voltage sensor. So here we are using 10:1 potential divider circuit. So from this continuously the microcontroller will measure the solar panel voltage, and whenever the solar panel voltage is above the threshold voltage, nothing but though we are using 12 volt 5 watt solar panel, whenever we place this in under sunlight, so it may provide up to maximum of 15 volts. So when we get the 15 volts, so we are using 5 watt solar panel. So in order to utilize the equal the power, then the current will be decreased. So then we'll get the less current with maximum voltage. So but we need only 12.5 volts maximum to charge our battery. Remaining voltage will be negligible. So then in order to regulate that voltage till 12.5, the microcontroller will making use of this MOSFET. So this section will called as a MPPT, maximum power point tracking purpose. So whenever the voltage is above 12.5, then the system will regulate the voltage to 12.5. Then we'll get the maximum current which we equal to the V into I equal to 5 watts. So then one more thing is there, boost converters. This circuit is a boost converter. So after this MPPT concept, so we will get 12.5 volts. If it is below the 10 volts, means 8 to 12 volts, whenever we get the 8 volts, so the microcontroller same it will measure the voltage. And after this MPPT circuits, we added the again this is all closed loop. So again we added here boost converter. So based on this MOSFET switching frequency, by charging and discharging of these capacitors, the voltage will be increased. Whenever the voltage is 8, then we will get the 12.5. So means constantly we are maintaining the voltage in terms of MPPT and also boost converters. So the constant voltage will given to the battery to charge. So here we are making use of a 12 volt 1 amp battery. So this battery pack is consist of 3 4 volt 1 amp batteries, so that we will get the 12 volt 1 amp constant power supply. And after this 12 volts will be given to this H bridge circuit along with step up transformer. So here the two MOSFETs will act as a H bridge circuit. So microcontroller will provide the 50 hertz pulses to this MOSFETs. So the MOSFET is a switches in between the step up transformer and the battery. So same pulses with 12 volt 1 amp currents. So the pulses will be given to the step up transformer. So as we know that the transformer will step up the 12 volts AC, as we have converted the DC to AC with the help of the microcontroller and the MOSFETs. So then the 12 volts AC will be step up to the 230 volts. So nearby we will get 180 volts to the 230 volts, and that AC voltage will be given to the load directly. So here we have provided the transformer also. Whenever there is no sunlight, so then we can charge this battery using the transformer. So let us execute the project with solar panel. Just we need to connect the S to the S here. So here we can add transformer or solar panel. So now the voltage coming from the battery, from the solar panel given input to this charging circuit. So here we can see there are the 4 diodes initially. So the main purpose of this diodes are bridge rectifier. When we connected the solar panel here, this bridge rectifier will not work as a bridge rectifier. Just it will allow the same voltage from this to the capacitor, and after this capacitor there is a LED indication. So as we can see this, due to the tube lighting also we are getting less voltage in the LED indication. And after this voltage will be given to the parallelly to the voltage sensor as well as to this MOSFET circuit. So here after this MOSFET, the voltage will be given to input to our boost converter. So the boost converter will get the trigger pulse here from the microcontroller, and output of the boost converter will be given to directly to the battery. And through this switch we are going to providing the input to this inverter circuit. And from this 3-pin connector, here we can see the 3-pin connector. So from this 3-pin connector it will get the pulses of 50 hertz, and that pulses will be converted into 12 volts 1 amp currents with the help of these two MOSFETs, and we will get the 12 volts AC here. And after this step up transformer, so we will get 230 volts directly here. We can connect maximum of 30 watts load on this section. So directly when we switch on this battery, parallelly the same voltage given as input to the transformer at this section, and with help of this 7805 regulator, so we will get constant 5 volts power supply, and that power supply will be given to the main power source to our motherboard. So this is just restart switch in order to restart the microcontroller, and this steel plated one is a crystal oscillator in order to provide the 20 megahertz clock frequency to the microcontroller. The main purpose of the oscillating frequency is, so we have provided some instructions to the microcontroller reading input and controlling the output modules like MPPT, inverter and boost converter. So these instructions set will be executed whenever it will get the one clock pulse to the one instruction. Like that we are providing 20 megahertz clock frequency per second, so that it will execute 20 mega instructions per second. So that's the speed of our microcontroller. So if you want to charge a battery with transformer whenever the sunlight is not available, just connect the T at the same slot here and provide the 230 volts input to this plug. So right, whenever we switch on this, then the light will be indicated here. So it is showing that the battery is charging with help of the transformer. So it will take 8 hours maximum to be fully charged, whether it is sunlight from the solar panel or to the transformer. So same time will be taken by the battery to be fully charged. Done. Thank you.